a community meetup, Orleans. We haven't done it in a few years, so it's a good thing to resume. We'll blame Richard Osbury, who's been running that he moved to Australia, to their own time zone. So let's see how it goes. We wanted to share some of the thoughts, early thoughts about Orleans for our kind of direction we're thinking about, and want to get your ideas and feedback and how to prioritize things, how to collaborate on that. So that's what we call back to basics, because some of the things we're looking at is to rethink things that been done in a certain way since the very beginning of Orleans. And Ruben's going to talk more about that. And then Ben's going to cover some of the aspects on the directory side, and want to leave plenty of room for discussion, ideas, questions, any random stuff. So Ruben, are you ready to go?
Sure thing.
Okay, take it over.
Okay, welcome everyone. Let's jump straight in. So the first thing I thought that we should go over was just a recap. I think Sergey said before that the last time we met was actually 2017, which is a bit, that's kind of our fault. But anyway, in that time, we released 2.0 and 3.x. So a lot of things happened, right? One of them being distributed asset transactions, which is now used in production. Actually, just down the hallway from us is some of the PlayFab team who are using that. We have the new scheduler that was contributed, which gave us nice, juicy performance boost. A new code generator, which now uses source code analysis instead of reflection. We refactored, this is not something we talked about a lot, but we refactored a lot of the internal cluster membership to make it cleaner and more reliable and recover more quickly. And in 3.0, one of the biggest changes actually that came into 3.0 between the 2.x branch was the new networking layer. So we worked with the Bedrock team, as in ASP.NET, David Fowler and crew, to come up with some abstractions that we could use. And one of the main driving factors there, not just speed, which was a nice benefit, but it was for implementing TLS support. So we have TLS support now in especially not .NET Core, but we also have a PR to add it back to Net Standard 2.x. We have the direct client, which lets you just call grains from any thread. So you don't need to be on an all-in scheduler anymore to be able to make a grain call. You can just co-host, say, for example, ASP.NET with all-ins and have your controllers call directly into a grain with the same iGrain factory that you just pull straight out of DI. So there's zero ceremony involved. And finally, we have support for the generic host builder. That's another collaboration with the folks in the ASP.NET team. We can now put all-ins and say ASP.NET, SignalR, gRPC, whatever, into the same container and host them using some common infrastructure. So one of the things that we did actually in the 2.0 timeframe was to try to delete a lot of the things that we'd built up over the years because they just simply didn't exist beforehand. Like for example, logging, dependency injection, we almost had none in the 1.x timeframe. But a lot of other things, and hosting is one of those where we used to have a separate exe that you would launch to host a silo, and all of that has gone away, deleting all that common code. Julian called it de-inventing the wheel, and I like that because, the idea here is to be working as an ecosystem, right? So that's the recap of what we did. But we're here to look forwards, so here are some of our initial thoughts on what we want to accomplish in the 4.0 timeframe. So you can definitely feel free to comment if you want, and we'd love to hear feedback on these. But one of the main ones is we wanted to revisit the core grain identity. And that's something we've been talking about for a few years, actually, because we'll go into this a little bit more on the next few slides. But there's a bunch of reasons for it. And obviously, it's a fairly fundamental shift. After that, Ben's going to talk about the pluggable grain directory, the idea being that, instead of using all-ins built-in directory, now you can provide your own implementations, which opens up a range of options. Some idea I remember Julian was a big proponent of this a while back, was POCO grains. So grains that don't inherit from a grain base class. In 2.x, actually, this is something we didn't include on the previous slide. We introduced this concept of facets. And what facets really were was actually just a way that you could have a dependency injection scope for your grain and then inject services like iPersistent state or transactional state or whatever else fully customizable sort of things into the grain via the constructor. So you don't have to inherit from grain of T in order to have state anymore. And that opens the options up quite a lot. So being able to remove the grain base class altogether, part of it is just getting rid of that magic, right? You don't want these magic things obscuring your understanding of what's going on. It's a similar kind of thing to what ASP.NET did, I think, in the between Classic and Core. Another one that really does bear some explanation is Bedrock Framework. So in 3.x, we have this Bedrock thing, right? And really, it's a set of abstractions. It's saying, how do we create sockets, and what do the underlying communications look like? And in essence, they use the pipe type. So they have span and pipe and memory pooling. But a lot of that code is actually still specific, copied into the Orleans tree. So for example, in order to create socket connections, we actually have a socket connection class. And the idea behind Bedrock Framework is to take what was started there and move it to the next stage where we're saying, let's have an abstraction, but also implementations of these types. And so you can go and get a socket, or not a socket, maybe in-memory pipe or whatever else, and have it provided, the implementation being shared. And one of the benefits there is you don't have to have, say, Orleans specific code for TLS. We can just have common TLS implementation or common logging middleware, for example. So that's one of the things we want to do. This other one, Orleans core, in someone called them scare quotes. The idea there is to take what we've got in Orleans. We have a lot of things built up, and slim some of it down and make some of the things more modular. And I'll give you an example. One of them is with transactions. When we brought transactions in, we had to add a bunch of things to the core of the framework. For example, fields on the message, or new types and code within the core invoker class that we use to make transactions work. But ideally, that kind of stuff shouldn't be required, right? We should be able to build those sort of things as purely external extensions using, say, grain filters and extensions to the messaging type. And so the idea there is to slim down a lot of those things and make them more external. So you can plug them in and customize them more completely, have a minimalistic kind of implementation. We want to improve support for distributed tracing. I know a lot of people are already running distributed tracing on Orleans, but at the moment it's not very turnkey. So it would be nice if, now that the W3C standard is, I believe, if not ratified, close to, and a lot of the tooling and infrastructure for distributed tracing is starting to mature, or at least starting to emerge, we can actually implement that more natively. And the next is very ambiguous, but to improve the experience for deploying on Kubernetes. We have a bunch of teams internally at Microsoft that are running already on Kubernetes. And so we've been getting experience there. And there's a few things I think that we could improve. Maybe make it a little bit more easy to deploy an application on Kubernetes that's running Orleans. Currently today, it just runs there like any other application, but there's no real, I guess, smarts involved, right? The framework it's not aware of Kubernetes or anything that's going on in the cluster. So we can look into ways to make it a bit more aware of that. And we doubled up the last point. We want to hear feedback about kinds of features that you'd like to see. And feel free, if you want, later to chime in and just throw some ideas around and we can have a chat about them. All right, so some of you might have seen this picture before. This is essentially a formulation of what a grain
I'm sorry, Ruben, can I go back to the slide?
Yeah, sure. Yeah.
I wanted to stress the last two bullets you see there on the slide. So these are the top one is the things that we have on mind and we're trying to work on. But since it's a completely open source project, features, any contribution, like your ideas, that's what we're after, right? That's the way to scale development and build stuff. Sorry, Ruben, keep going.
Oh, no, it's fine. Okay, so this slide here is essentially sort of the formulation of what a grain is, right? If you think conceptually or even philosophically what a grain is, you know, it's composed of identity, some stable identifier, some behavior, which is, you know, your implementation class, plus optionally some state. And really at the core, at the absolute center of everything is that identity. That's the main non-optional part of a grain. And today that identity is composed of conceptually some type and some key, right? So you say grain factory.get grain of I use a grain with some key. In this case, it's Fabio. And actually under the hood, what happens is you get a grain that's resolved to this user class. So it's not actually a grain that's referring to I use a grain as much as it is a grain that refers to user, this specific implementation with Fabio as the key, right? And you know there are positives and negatives to that. We'll talk about them a little bit. So one of them being that this class implementation essentially is hard coded into that grain that you get, and you know there's no separation of concerns there. So the type is really encoded as a hash of the class name in essence. Like that's the way you can think about it. Even though you can manually specify that, you can use the type code override attribute if you want. And the key is one of these following kinds of different types of IDs, right? Like you can have a GUID, an int, a string, or a combination of GUID and string or int and string. And that's good, but at the same time, it's kind of overcomplicated. I'll talk about that more in a sec. But one thing that also the grain ID actually includes is what type of grain it is what category of grain it is. And none of these really mean anything to you as a developer except for the grain type. So maybe that's something that really shouldn't be there at all. I'll move right on. So what are the problems with it? Well, one of them is, you know, we do a lot of diagnostics and troubleshooting for people. So we see a lot of these grain IDs in logs and match them up together. But these IDs are not really human readable. They end up looking like kind of a mishmash of, you know, some fixed text plus some type codes, which are encoded as hexadecimal strings, and then some long sequence of essentially opaque bits, again encoded, and then some optional string. And you know, that's not as friendly as it could be. And I think it can be a little bit off-putting sometimes. Another thing is that the key type itself, the ones I mentioned on the previous slide, these ones here, they're not actually encoded. The type of key is not actually encoded into the grain ID. So when you go in and inspect that at runtime, like in a call filter or in some extension library, so that you can either parse bits out of it or potentially change some behavior depending on what it is, you can't really do that. You have to kind of infer it. And the trick has always been to infer it from the interface that the grain implements, but that is not a surefire way to do it. So there's a little bit of a problem there. Another thing is that these generic type arguments that you pass to a grain are not actually a part of the ID itself. So instead, what gets encoded when you have, say, let's say I list grain of T, what gets encoded is 3 bytes of the hash of that T into the ID. But the full T type name is stored in the grain reference. And so there are a couple of corner cases when you're casting the grain around or, you know, how it's constructed that matter there. And one of the big problems here that is probably not called out easily enough or clearly enough is that it's difficult to serialize these things. You can't really know what you're dealing with or reconstruct them at the end of the day. Okay, so we thought, or at least I thought long and hard, and we came up with this alternative approach, which is that we'll just encode these things essentially as stringly UTF-8 sequences and have a user-defined type instead of some set of hash codes and whatever, and then a user-defined key. And we'll allow conversion from the existing grain IDs to these new IDs, and they'll be open and easy to serialize and construct and deal with yourself. And the way that we'll allow these friendly names to be converted into the .NET type resolved at the end of the day is via some extensible interfaces. So you can have a resolver and a formatter to go to and from the .NET type. And we have a work in progress branch of this with some early success. It looks good so far, passes BVTs, etc. But it doesn't fully realize the goals yet because it's still very much under development.
And I can jump in.
Yeah.
So
let me move back.
Because from the beginning, people were asking, why didn't you use strings as grain IDs? And that was fair feedback. I think it was a case of premature optimizations where we went for GUIDs will be very efficient. And I think nowadays at least it's clear to us that strings would be much more usable for people. So that's part of going back to basics and changing some of the early decisions that were done with different assumptions. Or the decisions were made with different assumptions at the time. Go ahead, Ruben.
Yeah, sure. So I wanted to show you essentially this is really pseudocode, but what it looks like. A part of all of this is removing things that are kind of magical and really that means opaque and hard to understand. But at the top, this example up here is really the least magic version of how you would end up getting a grain of a specific type. And it starts by manually constructing some grain ID. Then you next get a reference to it. And note that there's no typing on that grain reference that you get back. So that's just the base grain reference class. And then finally, this is something you can already do today. You take that grain reference and you cast it to a specific type. So that's like the very basic form of manually constructing everything. And so if you were to write, let's say, some generic controller that wanted to go and build something and then invoke it, it might end up using something more like this raw approach. But then as we go down, we start to see the more automated versions of it. Right, so a syntactic sugar over that top one there is in the middle here. And here we still are passing that grain type game-session there as well as the key, but we don't have manually constructed grain ID, right? Very simple to see how one goes to the other. But then at the bottom, what we see is really what we have today, which is client gets a grain of iGameSession with type the key is key, and under the hood it resolves iGameSession into the friendly grain type, which is game-session, right? So nothing too complicated, hopefully, and the user experience should look pretty much identical to how it does today, maybe modulo a couple of overrides, but it should open up the room there for a little bit more libraries and middleware, etc. As I mentioned before, we have support for the legacy IDs. And so essentially, if you have one of these legacy grain IDs, it can be encoded into the new type following some kind of a scheme which looks similar to this. And these fields here might not make sense, N0 and N1 and key X, etc. That's all just parts of the current internal grain ID. And those things will still not be very human readable unless we provide some kind of a resolver to give you, let's say, a C#ish kind of friendly name that corresponds to them. That's pretty much all I had on grain IDs. I don't know if it's appropriate to talk about that now, Sergey, if people have comments, or if we should wait till the end.
Yeah, I was thinking about the exact same question. I think considering that we have about 30 people in this chat, let's cover the directory first, and then kind of discuss everything together instead of splitting in discussion.
Okay, yeah. Okay, so I'll pass it over to Ben then, and he'll talk about what we're doing with the grain directory in 4X.
So, hi everyone. So I will talk about the grain directory, what's in it today, and what we want to change to make it better. So quick recap about the grain directory. Basically, it's just a lookup table to map one grain ID to a silo. Let's say grain ID X, the activation of grain ID X will live on silo 1 or silo 2. It is distributed. It's range-based partitioning. It's everything is in memory. Nothing is stored somewhere in storage or anything. So it's pretty useful because it's built into Orleans. You don't need to configure it. You don't have to install any external dependencies. It's battle tested. Basically, this code didn't change a lot for years now, I think. We made some improvement, but basically it's the same logic. And it's eventually consistent. There are some cons, basically. It's pretty sensitive to cluster changes. I will talk about that later on. You cannot customize it. You cannot change a default grain directory for this grain or not. And the con is it's also eventually consistent. So let me show you in the next slide. So here in this slide, we see a cluster of 4 silos, silo A, B, C, D. And silo C is, on silo C, we have.
Can you move to the next slide?
Oh, sorry. Change it. Okay, sorry. So here you can see 4 silos, silo A, B, C, D. And you see that on silo C, we have a portion of the directory that is responsible for the mapping of activation 1 and 3. Activation 1 lives on silo B, and activation 3 lives on silo D. What happens if silo C is gone? Well, you see that we lose all the information that were in the directory of silo C. That means that to be safe, silo B and silo D have to destroy activation that where the mapping was on silo C, which means here in this example, silo B will destroy activation 1 and silo D will destroy activation 3. Which means that on the next call targeting grain 1 or grain 3, we'll have to create a new activation, register it again in the directory, go again on the activating, etc., etc. So you can see here it can be a performance issue, like we are destroying perfectly healthy activation. But if you remember, I said also it is eventually consistent. Not everyone will see that silo C is gone at the same time. Maybe silo A still thinks that silo C is there and have activation that it should destroy and are not destroyed yet on silo A. So you might have duplicate activation for a short period of time, but still you might have duplicate activation. So it's hard to guarantee strong single instance in this case. There is also some other drawback. I don't think I can go to too much detail, but you can see that there is some drawback with this distributed directory. Again, it works well if the cluster is stable, but you see all this small blip when the cluster is changing, like when the silo is going down, or if a silo dies, etc. So the idea is to make the grain directory pluggable. That means that you can add your own custom implementation. You can configure everything via IDI, and you can even have different grain directory per grain type. Let's say you have one grain that is very expensive to activate. So on this one, you want a more reliable directory. On the other hand, you have like very short-lived grain. You don't want to pay the extra to go to storage or anything. You just want to use the default one. And you can think about different implementations that would be useful, like a storage-based one, like if that will not be sensible to cluster change. A consensus-based where everything is done via a consensus algorithm, a consistent hashing one, etc. The sky is the limit. You can whatever you want with that.
So I want to stress like one case here, which has been coming up all these years, like how strong is a single activation guarantee? kind of the programming model shows the picture that whenever you call a grain, there is one activation that you're talking to, which is true for almost all of the time, except in some cases, some rare cases in the race condition when cluster state changes. And so for the cases where a strongest single activation guarantee is important, plugging something which is more expensive, like storage-based or consensus-based, could be the right trade-off, as opposed to lightweight in memory only directory for all other grains. So that's what kind of per type configuration of flexibility would be allowed with this approach.
I think I'm done on the grain directory. Can go to the next slide.
Yeah, okay. So now we kind of just wanted to open it up and hear from you if you had any feedback you wanted to, or thoughts that you wanted to add there, and essentially open the floor. So feel free to unmute if you'd like.
There are some questions in chat while people are coming up.
That's true.
Like indexing, yeah, it's all open source, the indexing code and on Contrib, and it's built as a layer on top. It needs some investment and love. Like at the moment, we don't have much cycles to spend on it. But if somebody has cycles, desire to invest, we would definitely help with that. I think Harold mentioned CDRs and Kubernetes, and I think growing of the table over time, which shouldn't be a problem, I believe, with the latest versions where the auto cleanup was added back in like 2.4.
I don't know if the auto cleanup was implemented in the CDR. Okay.
CRDs, yeah.
CRD.
Yeah. And Adrian's question is also fairly similar. You know, whether or not Orleans silos could work with Kubernetes to sync up information. I think that means mostly based on membership. And then if they could scale up nodes in AKS. So you can already use horizontal pod autoscaler in AKS. It'll be better once the pluggable directory is implemented, because then you can have you can avoid those kinds of blips, because they'd obviously be exacerbated by your nodes scaling up and down so frequently. And also, to Harold's point, as I mentioned in chat, I've been experimenting with an alternative implementation of membership that works on consensus. And the idea there is that it would be usable in, say, Kubernetes type environments where you have nodes coming and leaving and you don't want to have those external dependencies. But certainly there is room to look at integrating more deeply with Kubernetes and the information that we can get just straight out of, say, service CRDs or whatnot to feed into membership.
I see Ashton's point that the new directory could help with indexing. It's actually a good observation we didn't think about. That, yeah, with storage-based directory, maybe indexing could be coupled with that, or integrated. It's a better word. Yeah, that good idea.
Hi, it's Jakub speaking. I just wanted to say that I welcome the work that you're doing on grain IDs. I think it will be really helpful to get a single string based implementation for the IDs. I presume that the same will be applied to stream IDs as well.
Yeah, so there is similar thinking for stream IDs. Essentially, it would be something like namespace /ID, right? I don't think there would be any need for any other components there. But we haven't really formalized that sort of thinking yet, though. Just initially, I think we need to think more there before we have really a firm answer.
So just a few comments from myself. the challenge that I have with a multi-tenant system is basically that I have to use strings because I need to encode the tenant as part of the Grain ID. And to be honest, I'm kind of using URIs for Grain identity. One thing that I've noticed is that sometimes I have several grains that work together in a kind of a child-parent relationship, and that's also encoded as part of the grain ID. In that sense, that you may have a user slash something ID, and then you may have user slash ID slash something else for a child grain that is used by the user grain. So that hierarchy is encoded in the grain ID as well, and I use that when I'm discovering the identity of the grain in the stream. So I have grains that subscribe to streams, and then they understand the identity of the grain that passed messages to them through streams from that grain ID string. So I think that it's quite important to get the grain ID and stream IDs, you know, to work together, as well as reminders. So another challenge related to the grain ID that I face is trying to find in the reminders table the reminders logged or created by a certain grain. So that's and that's a bit challenging as well, because the ID of the grain in the reminders table is that not very readable, it's not very readable format, and because of the problems with the or limitations of querying table storage, it is very difficult to find reminders for a certain grain ID.
Yeah, Jakob, all good points. Absolutely, like stream IDs need to be you need to match kind of grain IDs in concept and how they're implemented. But just tactically, we kind of started with the grain IDs to kind of solidify that, get feedback, can nail that design, and then reflect it in stream IDs accordingly.
I also find very helpful to have the an own identifier for the grain type instead of using the CLR type name. So that's brilliant. Do you know right now how, as a developer, I would encode or map those identifiers to types? Will there be an attribute I can put on top of my grain, for example, to specify that identifier, or will that setup be done in some other way?
Yeah, that's a good question. But before addressing that, I want to talk about one of your previous points. You mentioned that you encode grain IDs essentially like URIs. That was a big part of some of our discussions when deciding how many components, for example, should a grain ID have. Should it be 2? Should it be 3? Should it just be a URI, literally a .NET URI type, or whatever? And the reason we landed on 2 was essentially the argument being that Orleans needs to know mostly one part of it, which is the type, part of the ID, and the rest of it really should be fairly freeform. So encoding the other segments of your URI into that one string and then parsing them out should be easy to do. And obviously going fully freeform would be just a little too much overhead, right? Which I'm sure gels well with you anyhow. The next thing you were talking about was essentially how will that mapping happen? Today it's done using a fixed mechanism with an attribute to override this type code, right? Having an attribute to specify what the grain type string that essentially represents your CLR type is certainly makes sense, and I think that's definitely part of the plan. Underlying all of this, though, will be a mechanism that essentially has that mapping, and these attributes are used to feed into some underlying application model that is used to decide, to perform this mapping, right? And so you'll be able to, sure, use attributes for it, or perhaps use conventions, but either way, under the hood, it'll be a more sort of flexible, extensible system with, say, consider it similar to routing, with .NET, ASP.NET controllers, right? You can have them based on convention, or you can have custom routes encoded in, or you can provide interfaces that feed into that model. Same kind of concept really applies.
That's great. I don't know if you've guys considered the ability to change those mappings at runtime as part of releasing a new type of the grain. So I could have, I could release the code with two different classes implementing a grain with two different identifiers, have that, running in live system, and then changing the mapping as form of releasing new code.
So that would essentially be done on each individual silo to say, when I get a call for some grain, I really want to remap it to some other type. I need to think about how that would work with the current versioning support and heterogeneous silos, like if one supports the V1 and one only supports the V2. In the more symmetric case where you redeploy everything, and then at runtime you want to really like a feature switch over to a new class, I think that kind of thing should be implementable, if not, likely not a first-class feature, because it sounds very radical, but it's something that I think we should be able to do. It says POCO grains there on the screen, but there was this other, I guess, kind of crazy idea that I was throwing out, which I was calling no-code grains, right? POCO being plain old CLR object, no-code being no CLR object. And the idea being that you can just form these mappings at runtime more like a routing system, rather than actually having this core class which represents your grain. Obviously, that wouldn't be the green golden path, but the ability to do something like that might allow you to implement some kind of a switching mechanism like what you're really talking about.
I'm not, insisting, on that feature being there on day one. I don't even know if there is a huge need for such a feature. But just being able to use those feature toggles at runtime, if we can just make sure that the design that you guys working on won't stop such a development in the future, and takes that kind of functionality into account, I think that would be great. I don't insist that that's needed right now, but I just would like to ask you to have this at the back of your mind when you're working on the new grain IDs.
Yeah, for sure. It's a good point, right? Keep it in mind when designing all of this. Yeah, definitely.
Thank you.
Other thoughts, ideas, feedback?
Hello, this is George. I have a number of questions, but I'll interleave them with other people. So I've come from an ACA background before diving into Orleans. One of the two things that were really nice in aka.net was the event sourcing approach. It is fully message based, right? So as with everything in aka, but it was like a nice approach, I think, at least on the experience I had. Is there any are there any cycles or any plans to add a new approach for event sourcing?
So with the journal grain that we have, it's a kind of opinionated version which maybe in the hindsight should have been kind of put as more of a plugin on the Orleans contrib. So I think we're more than welcome to accept different approaches and different implementations, because there is no like one size fits all. Even like terminology wise, there are like some people disagreed with the way journal grain was designed. So like George, if you have a particular like layout for that thing, so let's collaborate and make it just another option or component.
Okay, so at least it's open. Okay.
Oh yeah, absolutely.
Sure. Yeah.
One thing we learned the most over the years is everything should be open.
Of course. Sorry for still using the Akka example, right? Another thing that was fancy, at least in the place I am right now, was the streaming DSL in Akka. So they have this fancy little domain language that they have that's similar to reactive extensions, right? It lets you write kind of aggregation-like code, yeah, but in a way that underneath the hood it's materialized into actors, right? That you don't have to know about, and it makes the scene processing aware of back pressure. So, for example, you can conflate things on the basis of your target not being fast enough to get them. Is this also open for implementation as an extension to streaming? I mean, I recall seeing something like this, some intention like this in the documentation somewhere, like adding expressions on top of the streaming infrastructure.
I think first of all, of course, we're open. I think here the challenge is, would that be done as part of a streaming infrastructure, which is harder because it has more moving parts, or naively on top of grains, right? At least that's my initial thought. There are kind of pros and cons for both.
Yeah. So like in the world of Akka, right? Streaming is not really distributed. So if you want to send messages from one node to another, it's still via actors, right? But the stream processing itself, right? It happens locally, right? So what Akka does is just creates a hierarchy of actors underneath the hood to sort all that out, and it just hides it into something into a language that looks like reactive extensions, looks like it. Right.
Well, I'm thinking that would be the kind of a straightforward implementation, not in terms of the complexity, but just conceptually, that you take some the main language like that and generate code that uses a bunch of factors. That's fine. Like that's a straightforward approach. I think what we learn in streaming is a lot of performance gains come from batching and those kind of optimizations, like putting things in the buffer, not deserializing every message like every time. So like to make it highly performant, my guess is some of those tricks would have to be applied to make it work at high load. And this is where I see space for making decisions, because one way I would imagine re-implementing some of those batching and serialization tricks on top of kind of grain graph. The other one is to go into streaming infrastructure and integrate with it, because it already does a lot of those optimizations. And I don't know the answer, just I'm pointing that there is this question there to me.
I guess the first step would be to show how Trill can integrate with this, because that would be local processing at least. Right.
Yeah, I think if you throw together a proposal and you should describe the language and what it should compile to, we can start from there and see, like, can it be integrated easily with streaming infrastructure, or is there a significant investment there, or can it go from a concrete use case?
Okay. Okay, understood. Thank you.
Are there questions, opinions, feedback, ideas?
How do people feel about the default chattiness of Orleans? Because as a new user that's just trying to get up the learning curve, I'm finding that I alternate between not knowing what's going on and having so much information dumped out by Orleans I can't find the bit I need. Is that just me, or do you think there needs to be a better controllability on that?
talking about log chattiness specifically, right?
Yes, the stuff that comes out in the console when you're running silos.
Yeah, it's a very tricky kind of balance, right? Because on one hand, you will absolutely destroy performance and maybe even the system if you log everything, right? Because it involves a lot of allocations and a lot of serialization in terms of memory and CPU threads, right? And then on the other, you know, you do want to be able to see some things. There's a lot of things you do want to see, and so a couple of approaches in distributed systems in general are sampling, so that you sample either traces or messages or something like that, so that you can output some subset of it. But essentially, when you want to actually determine which calls are being made by this call chain, it's you almost need to be able to specifically say that, you know, for these calls ahead of time, I want these all to be recorded, right? And that's the kind of thing that would be enabled by improving the distributed tracing support, so that you could actually specify, because I think there are typically interfaces like iSampler or something like that, where you say, should these calls be captured or should they not be captured? And so that kind of scenario, I think, is satisfied there. But otherwise, you can't realistically do that automatically, I think, from the runtime's perspective, just because it's really all or nothing.
And it's using its own logging technology, isn't it?
Sorry, what was that?
It's using its own logging technology rather than the Microsoft extensions.logging stuff, isn't it?
Orleans?
Yeah.
No. It's all Microsoft extensions logging.
Yeah. I wonder why it's not showing up on my syncs then.
They may not be configured. I'm not sure.
Okay, well, if it should be possible, I'll find out why.
Yeah, for sure.
I'm still waiting for Orleans as a service blade in Azure Portal.
Yeah, it's a popular request. Yeah, we've been trying to talk to the Azure people on and off. I keep pushing for that. Haven't succeeded yet.
You should get, you know, 3 Scots and Mr. Rasinovich, you know, in a lift, log them.
That's a good idea. Do you have a lift lock key? It's like a fireman.
I can see now on your 4.0 roadmap improved Kubernetes experience. Is this the maybe not preferred but or recommended but suggested way of hosting Orleans going forward? What about Service Fabric? I was actually considering, you know, using Service Fabric Mesh once it gets out of the preview. So, are you thinking about any improvement around Service Fabric, or if I want to use Service Fabric, it's just reliable actors?
Well, so we're running on Service Fabric internally at Microsoft as well. So there are some teams also around here that are running Orleans on Fabric. I think in terms of investment into native integration, a part of it is to go where the people are and where the need is greatest. And so what we've been being asked for mostly has been Kubernetes. And the existing Service Fabric integration, which is fairly lightweight in that it kind of provides you a really basic, here's how you run Orleans as a stateless service kind of a thing in Fabric. For the time being, I believe is sufficient. You know, nothing is out of the question, of course, though, but I think that's one area that would be especially more for community contributions than ourselves.
Okay, understood.
We haven't heard so far, oh, this is the bad idea. We shouldn't be doing X. Grain ID, Orleans core.
Well, if you're going with bad ideas, there's a bad idea that would be useful to us, and that's a very old bad idea regarding memory management, like having a way to deactivate grains on the basis of low memory in some way, in some automated way. Right? I know you can't do it manually. Yeah, I know that, but all the approaches you have right now are a bit flaky.
Oh, it's a good idea. So I don't know. Joking. It's bad.
No,
I
no,
just
yeah,
I replied
yep.
on that in
Okay.
chat because there was a discussion, I think yesterday or the day before, on Gitter. It should be totally doable. Just a question of expediting deactivating buckets of grains or activations in Asylum. And that discussion is that early reluctance to do that was because figuring out how much memory is being used in the .NET process was tricky, because .NET Memory Manager can keep a lot of garbage, like gigabytes sometimes of memory, which it can free up if needed. So if you just judge by the memory used, you may deactivate prematurely. So that was the concern early on, but I think now that .NET Core should be much more robust and provide more information. It's my assumption, at least. Ruben, do you know more about? Is it possible to accurately measure memory usage?
I'm not sure if it is. It probably is. But the point there being that .NET essentially will take memory from the OS and only return it when really needed. And so it's really lazy about that returning of memory, which makes sense from a performance perspective, but obviously makes it a little bit harder to determine how much memory is actually needed. Either way, I think it's something that people have asked for a few times, and there's been some kind of hesitation on whether or not it would be an accurate way of doing things. But I think opening it up to something like that makes total sense, right?
Yeah, and I was going to say the same. So long as it's configurable and it's an opt-in choice, it doesn't matter, even if it's inaccurate. If that works for your application, of course, that should be possible.
All right, thank you.
Oh, thanks for the question. I was hoping to see some, to hear some pushback. Oh, don't do this, because sometimes preventing bad moves is more important than adding good
Yeah,
options.
I kind of understand why it is a bad idea, because if you don't scale up, if you don't scale out when you do need to scale out, right? You may avoid trashing your hard drive, right? But you're going to end up trashing the data source anyway, because the grains are going to reactivate if you keep hammering the system. So it's not like you are avoiding trashing. You're just moving the trashing around. So.
Yeah, I don't see any problem there. So just a question of implementing. Totally. I was thinking more like somebody says, no, grain ID is a bad idea, or I don't know, pluggable directory is not the way to go.
I mean, if we are to pick some bad ideas, what is I'm just interested. What is the rationale behind Poco grains? What would be the end goal and the suggested usage that you're considering?
It's a good question. I mean, you could argue pretty fairly that like it's a feature without a need, right? And there's a couple of reasons for it. I think the primary one is flexibility, right? .NET only supports single inheritance. So if you have, let's say you have some kind of base class, if that base class has to inherit from grain in order to be used in Orleans, then you're kind of out of luck if you want to be able to change that or not have it be part of Orleans or a grain project, right? So it's kind of about opening that up, also about removing any of the magic that's in there, right? If something was a Poco grain, that would imply that you have to inject anything you need, which instead of it being automatically injected for you by the runtime. So it kind of makes it less opaque as to what actually is going on behind the scenes when you do something, at least in my view. hopefully that answers it.
Mm-hmm. So with the Parker grains, are you considering being able to achieve everything what I can do right now by deriving from the base grain class by having a dependency for every functionality from the grain class to be injected into my Parker class? So let's say, for example, I want to deactivate my grain. I want to kill my grain because I want to,
Yeah.
reload the state from the storage. So right now I can call on deactivate on idle on the base class. So if I don't have the base class, will the functionality for deactivating the grain be available as a interface or something that I can inject to my Poco class through the constructor?
Yeah. That's fair. Yeah, so actually it already is. I think in almost all cases, but deactivation especially is one of those cases where you can actually write a grain extension, which is like a very little known sort of feature that I think we need to make it a bit more prevalent, maybe. At least I like them. And a grain extension is like a library, or sorry, it's really an object, which is like a mix-in for a grain, and it can add interface methods on it. So you can say, I want to get the user grain, but I want to cast that to an deactivatable grain or something along those lines, right? And it can inject the grain runtime and then deactivate its host. So it gets added by the runtime on the fly to your grain, and then is able to interact with the runtime on its behalf because it's in the same scheduling context. So I put an example up on a GIST the other day that shows how to do that, and I can show you how to do that. But in short, the answer is yes.
Okay, cool.
I would kind of bubble it even one level up, right? So kind of the reason the grain is a base class, because that was the style of building libraries back like 10 years ago that was promoted by sort of .NET, the NetFX project that never shipped. And since then, the people moved from inheritance to kind of injection of dependencies kind of in the industry as a whole. So that's part of the reflection of the reality where people want to be, how they want to consume, instead of this magic base class or abstract base class methods have more explicit interfaces for specific functionality they want to consume.
Yeah. Also, I think as a design goal or general strategy, removing the need for that forces us to be honest, right? It has to keep us honest because we have to make sure everything can be consumed in some other way. So we can't just hide hidden functionality in the grain class that you're not expected to be able to access. It makes sure that anything has to be designed for being publicly consumed, which I think is just a nice forcing factor as well.
Okay,
Added benefit.
I understand. That would impact the stability of the grains hugely, because now I just have a standalone class, and all the features from the runtime that the grain is using are basically injected explicitly into the grain. So hopefully they could be mocked or stopped quite easily. Do you consider spending a bit more time on the testing side of the grains, providing some implementations for the runtime features that can be used in unit testing?
Yeah, so like for example, pre-mocked or dummy versions of reminder registry and schedulers and things like that.
Yes.
It makes total sense to want to do that. And they should be in the test kit, ideally, right? But at the very least, they need to be implementable by anyone else. Say using a standard mocking framework, you should be able to add that kind of stuff.
But at the same time, we want to be careful and not to try to provide like one size fits all. Like here's how you mock it, because everyone wants to differently. So it should be a reasonable level of kind of functionality / openness.
Yeah, for sure.
One more question for me about distributed tracing. I'm using application insights, and my basic requirement for distributed tracing is to get a nice tree of all the calls between the different grains in the chain, and be able to see that on the App Insights in the App Insights tool. Do you what is basically your end goal for supporting distributed tracing in Orleans? Is it the case of well, I will be able to basically hook it up to App Insights and I can get all that information out of the box, or will I have to as a developer to implement something in order to get, for example, the call chains between different grains?
Hi, Harold here. Can I just answer that one?
Yeah. Feel free.
We got Orleans logging to application insights, and we turned on tracing, and by default we had it for all our calls, and that just halted the whole thing because it logs so much when you start logging all the calls. So basically, you don't want to log all the dependency traces. We do it on a need basis, so we can enable it on the query. And that works quite fine. There's a bit of setup, and I can see with my customer if I can share that code for everyone.
Because, for example, from my experience, I would like to differentiate the amount of logging going on based on the grain type. So I may have a collection of grain types which represent some important actions, and for them, for example, I want to log the whole chain of activations and so on and so forth. See how they interact with storage or some other resources. But then I may have some other grain types which are less expensive and not that important. And for them, I'm not interested in that high level of logging. So I definitely want to differentiate the amount of logging based on grain types.
Yeah, that makes sense. I think the important thing is to enable those kinds of scenarios without providing them explicitly. For example, imagine you used a call filter and said, if this call is destined to X grain, then add a marker in the request context that enables logging, right? And then your implementation of the not Orleans provided, but standardized sampling interface, right? Like, for example, I think, is it Jaeger? It might actually be Jaeger's interface, I'm not sure. Typically, these libraries have like iSampler, and that's an interface that says, should I or shouldn't I record this trace? Something along those lines.
Mm-hmm.
So enabling that bridge between the two things, I think, is what's more important, rather than providing an opinionated out-of-the-box implementation of that. Does that sit right?
Yes, definitely.
So we're at the hour mark. So I think we need to start wrapping up. But it seems like there's a lot of questions to discuss. Maybe how do we discuss what to do next, like with the next meetup? Should we go over the issues on Orleans Country meetups repo? Because I don't think we're gonna settle now. Or Gitter.
I think issues is good.
Okay, so then let's wrap this one up and go to the meetup repo and discuss next topics. I mentioned that in the chat that I'm trying to recruit John Azariah to talk about some interesting Kubernetes silo work his team's been doing to present, and I think he was interested in presenting the next meetup. So maybe we have one more almost settled. But that may be like we dedicate to a meetup to some of the topics we discussed, like distributed tracing or resource management. Just have pretty much discussion meetup as opposed to presentation and discussion. So let's decide on the issues. Okay. Well, thanks everyone Thanks for joining. I know it's different time zone and different countries. It's good to see many people show up and participate.
Thank you, everyone. Nice to meet you.
Thank you very much.
Bye.
Yeah, thank you. Much useful.
See you. Thanks.